Alright class, the goal of today is to learn how to graph exponential and logarithmic functions. We'll be graphing these functions like we have every other function. We'll be looking at the parent and then looking at how we can just transform the parent. But I've got a disclaimer that you'll have to be aware of. So let's look at the objective and agenda. First, we're going to learn how to graph exponential functions by looking at the parent and then transforming it. Then we're going to learn how to graph logarithmic functions by looking at the parent and then transforming the parent. So first, let's graph exponential functions by looking at the parent function. So let's look at the parent. So this is what the parent of an exponential might look like. One thing we have to be prepared for is the fact that the base can be any number. So let's just take, for instance, y equals 2 to the x. Okay, so what I'm going to do is I'm actually going to open my calculator. So I'll minimize notebook, open up my calculator, and then I'm going to go to y equals and type in 2 to the x. I'm going to graph it, get an idea what this looks like. So I can see that it must kind of follow the x-axis and it shoots up here. So this area right here kind of looks predictable, and this area looks rather predictable. So I'd like to have a few points in here, maybe one point to the left of the y-axis. I would like to know where it crosses the y-axis. I think that'd be important to know, and another point to the right of the y-axis. So I'm going to go to my table, and I know that the y-axis happens when x is 0. So I'm going to take these 3 points right here, negative 1.5, 0, 1, and 1, 2. So my table gives me negative 1, negative 1 and 0.5, 0 and 1, and then 1 and 2. So I'm going to put these dots on the graph. Negative 1.5, 0 and 1, and 1 and 2. And then I basically just connect these dots. So it kind of follows the x-axis. It goes through these 3 dots, and then it kind of shoots up. So there's the graph of the parent function y equals 2x. Now, I said earlier that I have a disclaimer, so let me make sure I make clear what my disclaimer is. When I say the parent function, so let me actually type this, disclaimer. When I say parent function, you must understand that there are several types of exponential functions. So each type has its own parent, if you will. Let me put that in quotation marks. What I'm trying to say is we could have, let's say, we could have y equals 2 to the x, which is what we just saw. We could have y equals 3 to the x. We could have y equals 10 to the x. You could even have y equals 1/2 to the x. And last but not least, you could have y equals, which we saw last week, you could have y equals e to the x. So each one of these has its own parent. The example we just saw only works when my base is 2. If I have a base of 3, I have to figure out what the parent function is again, or at least what those values are. Same thing for 10 or a half or e. So you have to realize that there are so many different types of exponentials out there. I can't possibly show you every single type, but I can show you how you work with one, and then you just need to understand that if you switched bases, you would basically have to go back and do this step again, and then you could transform these points. So let's look at the next function. We're going to look how to transform the parent. So remember, we have this is going to either stretch or shrink the function itself. And these two values are going to move horizontal and vertical. Okay, and remember this is opposite keep. Opposite keep. Okay, it's always opposite keep. All semester long, it's opposite keep. So let's take a look at this. Let me see if I have an example, and I don't, so I'm going to make one up. Let's say that we have y equals 1/2 times 2 to the x minus 3, and then we're going to do plus 4. Okay, so what I have right now is I have my a value of 1/2, so this is going to shrink my function a little bit, and then I'm going to move right 3 spaces and up 4. So I'm going to go back several slides, and I'm going to steal this table that I made, and then I'm going to paste it in here. So you'll see what I do with these values. The first thing I'm going to do is I'm going to use this a value to multiply my y's. This will be very similar to what we did with radicals. So the 1/2, I now have negative 1.25, and then I have 0 1/2, and then I'm going to do 1. This is a 0, by the way. That's not a 6. Well, that looks horrible. It's a 0. Then I'm going to do 1 1. So that's applying the 1/2. So let me draw an arrow there to make sure you know what I've just applied. I just applied the 1/2 to get these values. Now I'm going to move my x values right 3 spaces and my y values up 4. So if I move negative 1 right 3 spaces, I get 2. If I move 0 3 spaces, I get 3. And if I move 1 3 spaces, I get 4. So I moved all the x values right 3 spaces. Now I'm going to move all the y values up 4. That gets me 4.25. That gets me 4.5. And this gets me 5. So if I plot these points, I will have my new exponential function. So I'm going to go to 2, 4 1/4. 1, 2, 3, 4 1/4. I'm going to go to 3, 4 1/2. And then I'm going to go to 4 and 5. So you'll see that this has actually been shrunk down. It doesn't necessarily grow as fast. You'll also notice something in a second I'll explain further, but it's going to follow y equals 4, and then it's going to shoot out like this. Okay. So let me go back a couple of slides and add a layer of understanding here. Notice that if I highlight this portion of the graph, you'll notice that the graph behaves asymptotically here. It seems to approach the x-axis but never touch it, and that is in fact true. So this actually has a horizontal asymptote. So I could say that I have a horizontal asymptote at y equals 0. Okay, so you should memorize this about most exponentials. They'll all have this horizontal asymptote. So if I go back, this also has a horizontal asymptote, but the difference is everything's been moved up 4. So this has a horizontal asymptote at y equals 4. The reason being is I took the y equals 0 from before and I've added 4 to it. So the asymptote comes up 4 spaces. So really, it would be a better graph if I did this. So you can represent that asymptote by drawing in a dotted line. So that's how you basically graph any exponential function. You would need to figure out what the values of the parent function are. Then you can multiply them by multiply the y values by a, and then move your x and y values based on h and k. If any one of these numbers is missing, you simply just don't do that part. You just don't change it in that way. So that's exponential functions. Now let's look how to graph a logarithmic function. First, we're going to look at the parent function, and then we'll look at transforming the parent. So, parent function. First off, this nice little, what looks to be a comma, shouldn't be there. So let me try to color over that. Well, that's interesting. So, that doesn't seem to want to disappear. So this right here, this does not mean a thing. This might as well just say y equals log base b of x. Now the most common log is base 10, so we're going to look at that. So then we're going to look at y equals log base 10 of x. That's what we're going to analyze, and that's what we're going to use as our parent function. But remember, what I'm about to show you will branch out to any of them. So I'm going to go back to my calculator, go to y equals. For some reason, sometimes the calculator hangs, so I'm just going to quit it and then open it back up. So go to y equals, type in log of x, calculator assumes base 10. Now I'm going to go to graph, get an idea what this looks like. It looks like it approaches the y-axis, so it looks like I have a vertical asymptote, and then it runs off here to the right. So let's go to my table. I'm going to get a few points in here. I'd like to see where it crosses the x-axis and get a point on either side. So I'm going to go to my table. There's where it crosses my x-axis because I have a y value of 0, so I know it crosses my x-axis there. Notice that I have errors when I get to 0 and beyond because this thing does not cross the y-axis, nor does it touch it. So this is going to be my first value, and then I'm going to use these 3 values. So 1 and 0, 2 and 0.3, and I'll do 3 and 0.5. So 1, 0, 2.3, and 3 and 0.5. So I'll have 1 and 0, 2 and 0.3, and 3 and 0.5. So those are my points I'm going to use as my parent. So I'll have 1 and 0. Let me switch colors so this stands out. I'll have 1 and 0. I'll have 2 and 0.3. And I'll have 3 and 0.5. So basically this follows the y-axis, and then it kind of shoots off this way. And I have a nice little vertical asymptote. To make note of that, I have a vertical asymptote at x equals 0. And that's going to matter here in a second. So that's how you graph the parent. I just found 3 points that kind of helped me describe it, and then I picked this point very intelligently. If you're ever graphing something, this works for me. This is going to work in pre-cal. This is going to work in college. If it crosses an axis, you better use the point where it crosses an axis. If it crosses the y-axis or the x-axis or both, you better label those points or at least use them in your table. So now let's look how to graph the transformation. I'm now going to transform the parent. So I've got of course, this a value, this is either going to shrink or expand it. My base I'm going to assume is 10. H and K are going to move it left, right, up, and down. So let's say we take what we were just dealing with, y equals 2 log base 10 of x minus let's do x plus 2 and then do minus 3. That way you've got some variation in your h and k in case you're wondering what happens with those. So if you'll remember, my previous xy table was 1 and 0, 2 and 0.3, and 3 and 0.5. And I had a vertical asymptote at x equals 0. So the first thing we're going to do is I'm going to apply this 2. So that's going to get me 1, 0, 2 and 0.6, and 3 and 1. Then I'm going to apply h and k. I'm going to move all the x values left 2. Don't forget this is opposite keep. Opposite keep. So move all the x values left 2. So that's going to get me negative 1, 0, and 1. And then I'm going to move all my y values down 3. So it's going to get me negative 3. This is going to get me negative 2.4. And this is going to get me negative 2. So this is what I'm going to graph. While I'm at it, I need to say what happens to my vertical asymptote. Since I moved left 2 spaces, my new vertical asymptote is going to be at x equals negative 2. So, in case you're wondering where my vertical asymptote is going to be, so the first thing I'm going to do is I'm going to draw my vertical asymptote. It's going to help me make sure that I get my graph correct. Then I'm going to draw negative 1, negative 3. So negative 1, 2, 3. 0, negative 2.4. And 1, negative 2. So this is going to follow along this asymptote, and it's going to shoot off this way. Okay, so that is how you graph exponentials and logarithmics. To repeat, you need to first figure out a few coordinates of your parent function, and then just adjust them accordingly to a, h, and k. Hopefully now that we've done graphing for the third time, because we've graphed quadratics and we've graphed radicals, hopefully you're getting a hold of the h and k idea and realizing how simple it can be to graph. So, like I said, that's graphing exponentials and logarithmics, and good luck.